Well, good morning, everybody. I've got a lot I'm excited to share with you today, including some new long-range analysis here. We're actually going to look back at last spring and talk about the forecast from last February for spring and kind of see where they failed. And then I want to just address why so many of the models are so wet for this upcoming summer. And we're just going to take a look at that, and I'll continue to build those ideas over the weekend and next week as well. But there's still a lot going on in the near term. So why don't we start off with some satellite data from yesterday? If we just watch the sun setting here across the east, I was watching four things. First was the convection here. Storms we knew would likely take on some of the environmental wind shear and rotate, which they did. We then had this really tightly wound low that came out of South Dakota to parts of Minnesota, and there was a very powerful low that came over parts of Arizona, just opening up the atmosphere to a lot of moisture transport into the mountains. And then there's this broad shield of cirrus clouds here that we just have to continue to watch, which is really symptomatic of the strength and speed of the subtropical jet stream. So pretty interesting day yesterday just looking at those four events. In terms of severe weather reports, we had 24 of them so far, including 3 tornado reports. And if you look here, the report that was in Wisconsin, this is the first time we've had on our records a tornado in Wisconsin in February. So looking at the Storm Prediction Center data, which goes back to the 1950s, I believe, that's the first one we've seen in Wisconsin in February. Now, these particular storms slowed me down last night. I was trying to fly them from Sioux Falls, and they had a ground stop in Chicago as the storms approached. Now, going to the snowy side of this, let me take a look here at the last 72 hours of total accumulated snowfall. As wave number 2 came through, remember, wave number 1 was the one out here. Wave 3 we're still waiting on, okay? As wave number 2 came through, we added more snow over the last 3 days into the Sierra Nevada, a lot here into the Rocky Mountains. Great snow getting added up here in parts of Montana into North Dakota. Brief heavy snows coming through South Dakota, but it was this right down here. Look at the heavy snows that came in and around Flagstaff, pushing up against the mountains in this area. We do have more information on the snowfall forecast coming to you. That's going to start in the Panhandles and end up in the Mid-Atlantic, so I'll get to that in just a few seconds. But I thought we'd just continue on with kind of this theme of keeping up with our winter precipitation. So here's a few slides, kind of covering some of the things we've spent a lot of time talking about this winter. First map, this goes through yesterday morning, and what it shows you is percent of normal snow. So not a whole lot of change in this, okay? We did see these numbers come up in parts of the Southwest. We're going to watch when this updates again today for these numbers to pop up again. But our bigger story about the places that have missed out on a lot of snow, including this region, and right in through here and pockets of New England, that's an area that still needs to see things getting filled in. Specifically looking at the Western Mountains, this is our latest snow water equivalent map, valid through February the 8th, and we've seen some pretty impressive improvement in the Sierra Nevadas, in the Central and Southern Rockies, and the Great Basin. Once again, just to make a comment here, the northern tier of this has been left out of the polar jet stream flow, which is why we've not yet really built up the kind of snowpack I want to see in place by the time we get to the month of March. We'll have a look at what March could look like in this area in just a few moments. Looking specifically at the Sierra Nevada mountains from south to north, we're going to start in the Tulare Basin first. And currently, if you look at what average is, currently we're just a hair below average at 11.7. We should be closer to like 15 inches of total accumulated precipitation down there. That's using these 6 stations. So that's some perspective down south. Let's go into this kind of the central stations here in the San Joaquin region. And again, we're off of normal. So normal would be about 21, 22 inches. We're at 16.1, but these events that have come through have really helped. And then if you go into the northern Sierra, these stations here, again, we're just off by maybe 2 to 3 inches from where we should be this time of year. I bring this up to let you know that the week 2 pattern continues to favor stronger jet stream flow once again to hit California. So we'll need to keep a close eye on that. The reservoir system, though, in California is not just healthy but full. Many of these reservoirs are reporting well above historical averages. As you can see, that's the number over here on the right. And this is going to be another year where California buys most of its water from just 2 to 3 events. And I think that third big event is on its way. In the Colorado Basin, the upper Colorado Basin, I just want to point out that we made a good jump here. We're now at 94% of average. About a week ago, we were about 84%. And there is more snow coming to the upper Colorado Basin in this forecast as well. But sticking on this theme of assessing water so far since the beginning of the new year, the hole that still needs to be filled in a large way is this region here. We've just made a case that the subtropical jet has dominated. We've not had a good polar jet, no good clippers rolling through this area, no nice systems that come out of California and race into this area. There was one yesterday, but it was weak. And so we have major holes in the northern plains, upper Midwest to fill in, especially on the snow side of it. Now, that's not to ignore western Texas. There's an area over here that's been quite dry. This very large climate district here doesn't reflect well the east to west differences across it. And do take note of the dryness in the coastal Carolinas here as well. The newest drought monitor released yesterday did show some pretty sizable drought reduction. And I want to do a couple of things with you here. Let's go to maps and then go to change maps. And I want to look at this, just the 1 week change. So we had up to 2-class improvement in the newest drought monitor update down here in the lower Mississippi River Valley and parts of the southeast. But I'd also like to just go up here and do a comparison slider. And I want to take you back to the beginning of the new year, January 2nd, and just show you the difference. So this would be January 2nd, and this is now. We would call this winter a drought-reducing winter. Okay, so it's not one where droughts continue to build, but we still have quite a bit more winter left to go. Another update on the 100 centimeter soil percentile map. Just take note that there are several places that still need to have another big push to get us to soak some of this in. Good news is it's mild right now, so any moisture that we can get in any of these areas will get into the soil and be used. And one last thing to update you on the Mississippi River. It's 21.5 feet above low stage. I don't know what was going on with their plotting tool this morning. I doubt that it has dropped back to that point down there, but I think it's more up here. But 21 and a half feet above low stage. Take a look at the temperatures. Now, this is what's happened since the end of the last Arctic outbreak, which we're going to talk about again in a second. So from the 23rd of January to the 8th of February, we have gone back over to a subtropical jet-dominated pattern. That's where the jet stream's just screaming zonally, not allowing for the really Arctic air to penetrate into the lower 48 and even into the Canadian prairie. You know, it's been a story we've been sharing in every video for the last couple of weeks. But I just wanted to show you the ranks. Very, very mild. Just very, very mild, late January to early February timeframe. I'll give you an update in a second on when that cold air might come back. But behind the front that just went through, temperatures did fall off 10 to 20 plus degrees as this front begins to advance farther to the east in the near term. But you know that our near-term story is being driven by these 3 short waves. So let's go and have a look at where they are. This was the lead wave. There you can see it right there, pushing the storm into Ontario and Quebec later today. We then have, this is kind of fun, there's actually 1, 2, 3, 4 separate little short waves all rounding the base of this longer trough. And I'm not going to say that they're going to compete with one another, but the ones to the south are the ones that are going to win to curl up this system this weekend over Colorado, which we need to talk about. And then here comes the kicker. So that's the third one that started off the week in the Aleutian Islands. It's here now. It's the one that's going to round the base, come out of the panhandles, and head straight toward the mid-Atlantic. So we're still keeping track of the same events we've been talking about all week. So at 5:15 this morning Central Time, most of the country kind of cleared out a lot of its advisories, but we do see winter storm watches in place here. And there's still winter weather advisories back in the Rocky Mountains, kind of running north to south here. So let's go and have a look at where the snow is going to be. I want to start you off with the newest data from the WPC. This is their map showing over the next 3 days the probability of getting 2 inches of snow. Now, not to ignore the Rockies here, but I want to zoom in and just kind of take a closer look at the southern plains and along the front range here. So this is the probability of 2 inches. Let's go ahead and step it up to the chance of getting 4. And you'll just take note here that right here along the front range, numerous cities and towns here, we're going to look at the chances for getting some heavy snow, getting down to southern Colorado, northeastern New Mexico, and then take a look at the panhandle of Texas. Now, we do expect this snow to spread kind of along this arrow that I'm drawing here, but we're going to have to flip over to the models to kind of see when and where that's going to come through. So, first thing I want to show you here is that in addition to this, we have today the risk of some stronger storms in parts of the Mid-South. Tomorrow, it's going to be down here in southern Texas, but it's going to be here on the 11th that I think we should take our closest look at where the risk of those strongest storms are going to be. So coming out of eastern Texas as the front kind of flattens out here into Louisiana and Mississippi. So to see all that, let's go to the high-res NAM. Pick it up at 5 a.m. We're going to watch one low curl through Ontario. We're going to watch the next one spin up that southerly wave. See it right there? And as we go forward, it's going to ride on this front. That's the front it's going to sit on. So low begins to curl up here. And here we are on Saturday afternoon and evening. And that is when on Saturday the heavier snows are going to start to show up here in the Front Range and kind of the, in the lead of the Rockies all the way through this part of eastern Colorado. The heavy snows begin in parts of New Mexico and the Panhandles. This would be Saturday night into Sunday morning. And what's going to happen is, so see that front? That's where it's lingering. This system's going to ride that front. And we're going to keep an eye to the south on the risk of severe storms. Now, the models are suggesting a line of storms coming through Texas at this point in the overnight hours of Saturday into Sunday. But I think we'll also be watching the heavier snows on the back side of this on Saturday night to Sunday morning. So that's what I've got. This is the high-res NAM. Now, this will be fun to watch. Do we get, like we just did with the system that came through South Dakota, a rapid transition and some big, fat, wet flakes right here behind this as we work our way into midday on Sunday? That'll be a big question to ask, but this system's going to roll through here pretty quickly. All right, next, I want to show you the model performance because we looked at this a lot. So remember, we've been in these kind of regimes of, 2 or 3 weeks of good model performance, and then they drop. 2 or 3 weeks of good and it dropped. We're back up here, and currently the European model is the better performer. So I just wanted to use that to let you know that when you watch these animations, just so you know where my eyes are, I tend to focus more on the right than the left. So I look at the right and then watch the left to see if there's good agreement. So the right is the European, the left is the GFS. So as we play through, we've already watched through Saturday into Sunday. Take note that Sunday morning at 12 a.m., when we're watching that snow spread out of southern Colorado into the Panhandles, western Kansas, notice the difference between where the models have the heaviest rain. Now we got the front stalled out here, but the heaviest rain dividing it up into the heaviest snow right in that same vicinity. So this is now 6 a.m. Sunday, midday Sunday, Sunday evening. Now the trick with this system is to understand if there is enough cold air on the backside to be producing snow as it comes out of the Panhandles through Oklahoma into Missouri, clipping southern Illinois on Monday, then into southern Indiana. Now, it's odd because normally we say this in the opposite, but the European's the quicker progression of the low than the GFS. And as the European kicks the system through, it does convert over to snow, hitting the I-95 pretty hard here. So this could be a pretty substantial snowfall event in this area. We'll take a look at what the models are saying. The GFS slower, curled up deeper. It's got a deeper wave overall. That's why it's slower. So it puts the snow there Monday night into Tuesday morning, into Tuesday midday. And the snow doesn't leave until Tuesday afternoon. Now that's the next big system to watch. After that, we've got just a couple of, they kind of look like clippers rolling across the northern tier of the U.S., but then all of our attention is going to go back to the west. And you already see that by next Thursday into next Friday, we have a whole lot more activity coming over the west again as the jet stream lines itself out. And we'll need to take a close look as to what happens after we get out there into not this weekend, but next weekend, beginning for the West Coast. It could be very active. Now, just take note that the models, okay, we're at 198 hours out, and you're going, holy cow, is this area going to get smacked? Just know that we have no agreement at that point. We're going to look at the ensembles in a moment. But let's go ahead and add it up. European model first, total precipitation. Played this out here through Tuesday into Wednesday. I'm going to park it out there at 1 week. So there are large sections of the country that miss on this. And then very wet down here across parts of the south, mid-south, southeast. And we're going to wait for the west for the return of moisture once we get the jet stream lining back out again. That was the European. Here's the GFS over the same time frame. And if we just kind of look at them back and forth, there's decent agreement overall, but you'll note that the GFS is much wetter in parts of the southeast than the European is. And the GFS is quicker to return the wetter conditions to Northern California and Oregon than the European model is as well. How about the snowy side of this? A week's worth of snow. Now, as we play it out there, that's through Tuesday. I'm going to park it at 1 week out so we can see the full on, all of it. I have the best, I think, ideas about snow here on amounts. This is going to be tricky. And the models are going to mishandle this. They're going to get the snow ratios wrong. So are the meteorologists, by the way, which means you're going to have to kind of nowcast it through. I just want you to see that there is the chance of getting accumulating snows here. New England, take a look at the model differences here. There is the potential, as you can see in my forecast from the ECMWF, of grabbing the spread's pretty large. But the positioning is going to be challenging, which is why we're going to look at the ensembles in a moment. Also take note, the Northern Rockies getting into British Columbia, adding quite a bit of good snow too. So are parts of the Sierra Nevada. I'm sorry, the Cascades out of this. What's the GFS have? That's the GFS. So again, what a challenging forecast here through there, especially in Oklahoma as this comes out. Again, the European GFS. Take a look at New England. Much farther south in the GFS than the European. Tricky forecast. So let's go ahead and look at ensembles. This is where I think the most important analysis can happen. This is the chance of getting an inch in the next 7 days. If we step it up to 3, you'll see that, yeah, there's a 40 to 50% chance, maybe 60% chance in a few pockets here. But then I think the greatest probabilities are back west and then here in New England. And so if we just kind of use this as a gauge as to where the heaviest snows could be, I think that's what I'm going to have to do. I'll just have to say, trust the ensembles, watch the system evolve this weekend, and then we'll get a better idea into early next week as this moves over. You also note that there's very heavy snows coming up here to the Northern Rockies. We need this big time, right? I showed you that at the beginning. We've got to get snow back into this region. So coming back, oh shoot, I lost the tab I was on. Which one was it? Oh, good, here. Let's go ahead and step it up to 6. And we'll go up to 12 just for completeness. So again, there's decent chances of some heavy snow in places. All right, as we think forward on this, you know that one of the big issues I've had in this pattern is the MJO getting stuck in phase 7 for a while. And some of the models are forecasting that by the 3rd week of February, instead of popping out here, giving us better risk of colder air, it's just dying into the null phase. And what's important about that is that this is going to put the Pacific jet stream, I think, on a bit of a repeat. And we look at out there past this weekend into early next week. Take note of this. What we have here is another extension coming toward the west. And by the time we get out there to the 16th, 17th, 18th, that is expected again target California. We've now seen this happen twice just in the last, 2 to 3 weeks. And this could be the 3rd big event that hits California. Right now, some of the models are suggesting that the probability of this getting up into the moderate category in terms of its strength as an atmospheric river, it's showing up as a possibility out here past the 15th toward the 16th. But at this point, I just want you to know that the risk is there again in week 2 to be quite wet in the west and all across the southern tier of the United States. So that's been a very consistent theme all week in the forecast. Without, a polar jet, without the jet stream kind of pulling toward the north and east and instead staying south, we don't have reason to give heavy rainfall here and snow, and also the same thing in this whole area from the northwest through the Canadian Prairie into the northern plains. So we're just still dominated by the subtropical jet through the month of February. Now that's also going to affect temperatures. All right, we know we've been thinking about this post-Valentine's Day cold air event. Well, let's see where we are with it. Let's go back and pull that back up again. I didn't mean to close it. That's my max temperature graph. There we go. So here's today, and it's, 70s. This is nuts. I mean, it's kind of fun, but very mild before the cold front comes through. So tomorrow's a bit cooler, but I say cold front comes through and it knocks it back down to still being 7 to 10 degrees above average into this area. Very mild east, colder air in the southwest. This is the support for the snow right here. As we go from Sunday into Monday and Tuesday and Wednesday, we just hang on to our warmer bias here. And then it's next Thursday after Valentine's Day that you start to see the cold air coming back. Now, from that perspective, let's now go look at day 5 through 10. And you can see where after we push the cold air out of Alaska, where it's sitting. And then day 10 through 15, the latest GFS run, and the European followed it, did not break down the mild air in these areas, which means the potential extent south of this colder air is being limited significantly. And we kind of just ask, well, why? Why is that the case? Well, you go out there to day 10, and we do have decent higher heights over Alaska, the Chukchi Sea, Greenland, but the positioning of our troughs is all wrong. And what I mean by that is if we want to really drive cold air in here, we need to be seeing the tropospheric troughs sitting on top of that cold air, and it's not there. So that doesn't make any sense. Can I just show you this? When we go back to that time period of the 9th through the 19th of January, we had the same kind of cross-polar ridging, but instead of having, which we do now, a trough here and a trough there, the trough of cold air was tucked in the middle, and that's where the cold air funneled. What was important about that, why this was made possible, was because the MJO back in that time frame was here, come out of phase 3 to phase 4. So we had this movement of the MJO out of its coldest phases into this area. So there's about a 1 week lag in that, and that's what helped. Well, what are we doing now? We're on the wrong side. We're diving into null space, and so there's just no reason to make a big call for long duration extended cold air. It's just not there in the models. So we get to all of this and say, well, where did we end up at the end of February and beyond? As we think about that, I want to show you the upper level heights playing through the end of February into March. And what we're getting out of this pattern in March is likely going to be a relatively decent push of Pacific moisture, but flow coming in like this and then making the turn. And as we see that, remember, northwest flow in winter is convergent and it is drier. So we look at all of that and say, well, let's go in here and have a look at the 30-day precipitation compared to average. We'll zoom into the United States. And as we play this out, I don't know, let's just go all the way to the 20th of March. We end up getting, try that again. End up getting this whole region showing up wetter, this region showing up wetter, a little bit of a drier stripe in between and drier in the northwest. And we've made an argument about this pattern, right? We said, well, that's what we expect as we go into March. We tend to be colder here, more mild there. We tend to have wetter conditions here, wetter there, and then drier stripes on either side. And the reason why that it looks like this is because this is very classic El Nino March behavior. Now, I'm going to do something in a moment, and that is to completely skip over April. And that is because I can't give you a classic April look for El Nino. And El Nino's there, but you say, well, why not? It's because April is probably the most difficult month of the year to forecast. It's a massive transition month. A whole lot of sunlight is gained during that month. The atmosphere is opening up to more spring-type convection, and it's just nearly impossible to forecast longer range. So April is a month we typically now cast through. But what will be driving most of our forecasts is going to be this. So sit and listen with me here. Our El Nino is still very much present. Is there cold water trying to surface underneath? Yeah, we showed you that last week. I want to make a case for a couple of things. I'm going to watch most carefully here, here, and here. Now, El Nino will be doing its thing in the background, fading slowly. But it's going to be the transition of the ocean temperatures here and here, which will ultimately be determining what the longer range forecast is going to look like in the models. What I'm going to tell you right now is this. For us to not watch the models, but to watch the observations, the key thing in the forecast, which is keeping so much of the area east of the Rocky Mountains wet, is that the models are not cooling off the Pacific Meridional mode, nor much of the PDO. So El Nino is kind of playing second fiddle to those two things, and I want to make a case for this for you as I wrap this up today. All right, ocean temperatures. How quickly is El Nino fading? Not quickly at all. We didn't expect it just to fall off to nothing so quickly. So if we just kind of extrapolate this out, it's going to do something like that, which means this is February, March, April, May. May and June, we could be talking about INSO-neutral conditions. And to be honest, that's kind of what we're seeing from the CPC. They're saying that by May, June, and July, the highest probability, actually it's in April, May, June as well, will be INSO-neutral conditions. So we expect spring INSO-neutral. But there's been some misinterpretation of this. And what I mean by that is, sure, the highest probability of the Pacific Ocean state is going to be La Nina by fall. But some people see this and interpret it as the strength of the La Nina. That's not what this is saying. This is looking at the probability of La Nina being there in any form. What's the difference? Well, if the ocean temperatures are just, 0.3 to 0.5 degrees C below normal, versus 1.5 to 2 degrees C below normal, that's an entirely different regime. So we need to be very, very careful with this analysis. But let's go through and see what we've got. The first thing I want to show you is the most aggressive model, the CFSV2. It's wanting to take this and put us into neutral conditions here by April into May, and then by July, have this be closer to 1 degree C below average, and then by October, almost to 2 degrees C below average. That is the most rapid in terms of the models at bringing in the demise of El Nino and the rise of La Nina. And it's one of the reasons why, when you look at these 3-month sliding window of precipitation anomalies, that the CFSV2 is a bit of an outlier. I mean, especially look at this. This is July, August, September. The model went very aggressively over to dry conditions. You say, well, why would it do that? Because if El Nino collapses, we tend to get like omega blocks here. And that's what it's saying. Now, it's one model, and I need you to know that it exists, but we have to be a bit more tempered in our understanding of this because that is one model that goes into the National Multi-Model Ensemble. And the May, June, July forecast currently does show La Nina, but keeps this very warm, warms up the Pacific Meridional mode, and it warms up the Gulf of Alaska. Now listen, if this did not stay as warm, and this was cold, and this was cold, then we are on for major drought risk in the midsection of the country, while the west tends to be wet and the east tends to be wet. Now, the east is the biggest wild card in all of this because of the hurricane season that will follow. But the model is trying to push a bunch of mild air into here. And I bring this up because if you look out there at the March, April, May forecast, we saw that the GFS, Eric. We saw that the National Multi-Model Ensemble went wetter in this whole region, drier out of Central America and Mexico into Texas and New Mexico, and a bit drier in the Northwest. It then said for April, May, June, keep the wetter risks alive. Bring the dryness here into the high plains. Keep it in the Northwest. The model also said in May, June, July that if there's an area that's drier, it's probably going to be the western and high plains compared to average, wetter to the east. So why did it do that? Why did this model say that that was going to be the case? I think the biggest reason for it is here. One more. It's not bringing in cooler water there. And that would be the strongest signal for it to go over drier in those areas. Just so that you know, though, the NMME that I show you is this map. It's the compilation of all 8 of these forecasts here. So these are just different global models. And some of them are even more aggressive than the CFSV2 on the drought conditions for summer, like NASA's whatever it is, this one, the SFV2. I mean, it is extremely aggressive on developing La Nina and cranking out just heat and drought in this area. So it's a suite of models we're looking at here. I do want to point out that the International Multi-Model Ensemble, though, for April, May, June, and then beyond, is wetter in this area. So just some things to consider. Next, what about the European model? The European model for ocean temperatures is also bringing in La Nina, but much more slowly. Rather than by May and June getting a full-blown La Nina going here, it's just more reserved. It's slower. It still keeps the waters warm here, no strong signal in the negative PMM here, nor the cold water in the Gulf of Alaska. And that's why this model, if you come through and take a look at its seasonal projections across the United States, there it is, March, April, May, June, May, June, July, August. It tries to build in the heat and drought here, not east of that line. You see what I'm saying? So I'm just trying to explain why I think the models look the way they look. And we just have to take it for what it is. Can I show you something, though, before you put so much hope in these models? This would be another aspect of this. If we look at every El Nino year that was considered moderate to strong to very strong and go June to August, this is what we end up getting in terms of precipitation anomalies during the summer. It's very interesting. We tend to be dry and through a corridor here and dry in New England. There was a wetter area tucked away here, but a little bit drier to the north of it. In the west, remember, June to August is not the wet season, so we often don't look at the west in these analyses. This is what I want to tell you. Just like I made a point about April, June to August during transition years, each one of these years has a different flavor to it. So I think that using these analog years to predict summer right now, because I can't make a finer selection of which ones are probably the best, you have years that were phenomenal for crops, like 16, and you also include in there 1988, right? Those were both years that transitioned out of El Nino. And so just understand, there's a lot of uncertainty with all of this. And if I could just do my best to add even more to this, can I show you something? This was the forecast by the National Multi-Model Ensemble from last year in February. Now I want to do 2 things here. This is what the model suggested April, May, and June would look like last year. And I also want to show you, remember that model I mentioned that was super aggressive this year on being dry? Last year it was super aggressive on everything being wet. So I don't look at this one for a reason. I also want to show you this. This was the European model forecast for May, June, July. And if you need a reminder, this is what happened. Pretty epic failure last spring of the forecast models in February to tell you what spring and summer were going to look like. And that's where we are. So if you get a hint in my tone that I don't know, I don't. I can look at a lot of things, but constructing this in a way that gives you some sort of confidence is just not capable right now. So just beware of folks that feel like they're overly confident about summer. I just don't think we can do that yet. We just don't have the reasoning for it. So I want to make one last point here. I made a big stink about ocean temperatures here and here. And I want to tell you why I care so much about these ocean temperatures. Because instead of correlating with El Nino, I'm correlating instead with the negative PMM or the PDO. What you need to see is this. Let's blow this up so it's a bit easier to see. If we say summer and look at the PDO, if the ocean temperatures in the Gulf of Alaska go warm, everywhere that you see the warmer colors has a better chance than not of being wet. That's why the models are wet right now, because they're all predicting warm water here. What about the PMM, the negative Pacific Meridional mode? They're predicting, remember, for it to be warm as well. And you say, what does that matter? Well, that tends to make it wet everywhere that you have the warmer colors here. So when I look out there and I see these longer range forecast models, let's just go back and look at it one more time, monthly SSTs in a global fashion through August, and I don't see a cold signal showing up here, that is why the models are reluctant to put down drought and heat. So you need to, with me, watch this. Now that's just one aspect. The Atlantic's a whole other monster, but that's one aspect that I'm going to pay the most close attention to going forward. Okay. We are now deep into this video. Let's talk about somewhere else. How about South America? Remember the front we talked about yesterday? Look at the storms that it brought through. And as the storms came through, they put down quite a bit of precipitation. In the last 2 weeks, there had been almost none. And just yesterday, look at what came through parts of Buenos Aires. And today it's going through Cordoba into Santa Fe. It's going to continue to advance to the north. The northern growing areas, the center west, like Mato Grosso, getting over to Tocantins, Goiás, Minas Gerais, which is here, and Bahia, plenty of rain. If there's been any area that's missed out, it's been southern Brazil, parts of Paraguay and Uruguay. In the forecast, more rain expected for Argentina, ending this 10 to 12 day heat and drought episode. We're a bit drier in Paraguay and southern Brazil, wetter in the northeast. That tends to be the consistent signal I got out of South America. I'll give you more in South America next week, but I'm going to wrap this video up here and just say thanks, and I'll talk to you again soon. Have a good one.